Initial calibration of the suspended solids probe for a given sample matrix like this aeration basin is necessary. Initially, a reading of the suspended solids in the aeration basin is taken and recorded by the operator within the instrument. Following the initial measurement, a grab sample is required from the exact location where the measurement was taken. Each different type of sample matrix within a plant may have slightly different nuances, and this difference needs to be calibrated within the suspended solids calibration. The sample is collected and sent off to the process control laboratory for suspended solids determination. To calibrate the suspended solids calibration curve in the TSS Portable instrument, we first go to the menu key and press Enter. Pressing Enter again enters the calibration menu, and we will choose to build a calibration curve for suspended solids on CS1. This is the first of 4 calibration curves. Notice down below there are no data points automatically stored from the factory. With the probe in the aeration basin, we press the Enter key and we choose to do a 1-point calibration by pressing Enter, in this case while the probe is in the aeration basin itself. Memory simply means that the probe is memorizing or taking the reading on the suspended solids content in the aeration basin. Notice the point has a star next to it, which means that we have not instructed the instrument what the actual concentration of suspended solids is. We'll need to get this from the laboratory. We can exit by pressing the clear key a couple of strokes, and you may even get error calibration. That simply is telling us that we're only halfway there. We have the reading, but we don't know the concentration at this point. We can turn the instrument off and wait until we get the data from the lab. The determination of total suspended solids using the gravimetric method is one of the most common measurements performed in a wastewater treatment plant's laboratory. In drinking water, the unit of measure is commonly turbidity, but in wastewater, it's typically total suspended solids. The procedure is detailed in the 5th edition of the Water Analysis Handbook, although it's referred to as non-filterable residue. Essentially, in the procedure, we take the sample, as in this case, the grab sample that was collected from the aeration basin, and we filter a specific volume of sample through glass fiber filters. These glass fiber filters trap the suspended solids in the sample, and we can dry the liquid away and determine the mass of the solids per unit volume gravimetrically, that is, with an analytical balance. In an aeration basin, the suspended solids is actually the activated sludge, that is, the microorganisms that we're using to treat the sample. The filtration is performed in a vacuum filtration device as shown here. A filter element that has been pre-washed with deionized water, dried in an oven for 1 hour at 103 degrees Celsius, and cooled in a desiccator so as not to collect additional moisture from the atmosphere, is initially weighed to determine its initial dry weight. The pre-weighed filter is placed on the top of the filtration apparatus, and a funnel is secured in place. This will get a little bit loud when we do the process, so I'll describe it first. A volume of sample is transferred to the funnel, and we draw the liquid through the filter element, trapping the solids behind. We then wash the filtrate with about 3 10 ml portions of deionized water. In this case, we used a 3 milliliter volume of the aeration sample. Any larger volume would pre-clog the filter prematurely. It's also a good idea to make sure that the liquid that has passed through the filter is clear in this case, to ensure that all solids have been trapped on the filter itself. The filter containing the residue is then transferred to a watch glass and will be dried in an oven for 1 hour. The filter containing the residue is placed into an oven at 103 degrees Celsius for a period of 1 hour. During this time, the water is evaporated off, leaving the dry weight of the residue and the filter element. After 60 minutes in the oven, the watch glass is removed and placed into a desiccator to cool. After cooling to room temperature, the dried filter plus the residue is weighed again on a 4-place analytical balance. And the gross weight is recorded. The calculations for suspended solids, otherwise known as total non-filterable residue, is very straightforward. To determine the milligrams per liter total suspended solids, we simply take A minus B. In this case, A represents the weight of the filter plus the residue after the filtration, and B was the original weight of the filter itself. we divide by the sample volume in liters. In our example for the aeration basin, the volume of sample that we filtered was 3 milliliters, or 0.003 liters. The weights from the balance was 0.1280 grams, or 128 milligrams, after the filtration, and 0.1233 grams, or 123.3 milligrams, before the filtration. Multiplying times 1,000 converts grams to milligrams. We take the difference, divide by 3 milliliters, or 0.003 liters, and we come up with a true gravimetric suspended solids determination of 1,567 milligrams per liter. This value will be used to update the calibration in the TSS Portable instrument. Once the data is back from the lab with the gravimetric determination of suspended solids, we can update the calibration point in the instrument. We scroll to the right, access the menu key, and again enter into the calibration menu. The calibration curve we are dealing with is DS1. We'll drop down to 0.1. Notice again it has a star because it has not been instructed the actual concentration of the sample. We press enter and update the memory to the actual concentration determined in the lab, in this case 1,567 milligrams per liter. By pressing enter, the data point will be saved, and we now have an accurate suspended solids calibration for the matrix in the aeration basin itself. We can now use that to measure all sorts of different samples in that particular matrix. If we were measuring a different point in the plant, for example the effluent or a primary clarifier, it's probably necessary to do another calibration on that given matrix. Once the probe has been calibrated to read the reading from the process control lab, the probe can then be used directly in a variety of different types of samples in that same aeration basin to read various concentrations. As long as the sample matrix is similar to that of the aeration basin, the same calibration could be used in other parts of the plants. However, if taking measurements in certain parts of the plants, for example primary versus final effluent, a new calibration based upon a gravimetric suspended solids determination from the lab would be necessary.